organized. Today, our goal is to be able to look at a graph, look at a table of values, look at an equation and know, yes, this is a linear equation, or no, this is not a linear equation. That's it. Linear or not linear. Okay? So first of all, when I say the word linear, what do you suppose the graph is going to look like? What'd you say? A line. Hence the name linear. Line. Okay? So, if we have a linear equation, so we're going to first talk about the equation. We are going to have something that looks like this. Oops, I don't want that. Like y equals 2x plus 3. Both x and y have exponents of 1. And they're not being multiplied or divided together. They're like separated. Okay? So, x and y both have exponents of 1. And we could use our Joey, what was that section you really didn't like? No, like what did I call it? In chapter 1, the literal equations. If I were to solve a literal equation, we could make it look like y equals something x plus something. Okay? I literally could not think of that to save my life. Okay? Now, if we have a linear function, then we have a non-vertical line. Why am I saying non-vertical?
Because it's not vertical. It's horizontal.
Okay, but what's true about a vertical line or not true?
It doesn't go down.
It doesn't go side to side.
Diagonal or straight.
It fails the straight line test.
A vertical line is not a function because it fails the vertical line test.
It goes on.
Okay? So a vertical line isn't a function. Okay? Now, when we are talking about not looking at a graph, something that we're going to talk about a lot is that a linear function has what we call a constant rate of change. And we'll talk a lot about what that is and what it means. Okay? Now, when I say something is non-linear, guess what that means?
It's not vertical line.
Okay, well, it could be a vertical. It's not a linear function. So basically, anything that doesn't match these descriptions is non-linear. Okay? And your whole goal today is to look at a relation and determine, is it a linear function? Is it a non-linear function? A vertical line is just not a function altogether. Okay? Okay. Now, I do want you to make a note down here where it says notes. If we have a vertical line, we all know what it looks like. Now, we haven't talked about what the equation that matches a vertical line is. If I have x equals any number, I'm just saying a for, it could be anything, x equals 5, x equals 2, x equals 17, that is going to be a vertical line graph. Okay? Just in case that pops up. I don't know if it will. Okay, so when we go to the next page, we have one graph that is represented in a bunch of different ways. I guess I should say one relation that's represented in a bunch of different ways. So when we look at this equation right here, I notice that y and x have exponents of 1. We don't see any exponents on them, and they're separated. Okay, so I know that this is a linear function. Okay, what I want you to notice about the graph, what does it make? It makes a line. It makes a line, a non-vertical line. Okay, now when we look at our input-output, either tables or our mapping diagrams, we need to look for that constant rate of change. So answer me this. If I go from -1 to 0, we go up 1, right? How about 0 to 1? Okay, and 1 to 2. Up 1, right? Now, what about when we look at the y column? Going from 2 to 3 means we went up 1, 3 to 4, and 4 to 5. Now, I don't care that the blue and the red numbers are the same number. That's not going to happen very much. But what we need to make sure, is this a constant rate of change? Yeah, we're +1, +1, +1, +1, +1. Is this a constant rate of change? Do my y's, do my outputs get bigger or smaller at a constant rate? Okay, so here we have a constant rate of change for both the x's and the y's. So we're good. We know that that is linear. Okay, you guys? I mean, that's pretty much all we have to do. Okay, so we're going to go to page 68 and we're going to answer some questions together. Okay. All right, I have two graphs. Linear or nonlinear? What do you think about number 1?
Linear.
Question, is that a straight line? No, it's not a straight line. It's curved, isn't it? Like, doesn't it curve?
Yeah, that's not what a vertical line does.
I don't care about a vertical line. Is it a line?
No.
Could I draw this with a ruler?
Yes. Yeah.
Nonlinear. That is a curve.
One of those bendy
Okay.
rollers.
Can I draw that with this ruler?
Spin the roller.
No. But could I draw this one with the ruler? Yes. MG, you have something to say?
Non-linear means the line is not linear.
So, and you said parabola? So a parabola is just one type of nonlinear equation. We have lots of them. Is that your question? Okay. So a parabola, which we'll talk about second semester, is like y equals x squared. Okay? All right, so now let's look at these. Okay? When we look at number 3, do our x's have a constant rate of change?
Add 1. Yes.
We add 1 to get them. Okay, so make sure you write that down. Okay, what about our y's?
No. It's adding 3.
Isn't this plus 3,
Yeah.
plus 3, plus 3?
Yeah.
Okay, the x change and the y change don't need to match. They just have to be consistent with each other. So my x's are consistent, my y's are consistent, so this is a linear equation. You and your elbow partner decide about number 4.
No. I'm just crazy. Because, okay. This one's easily non.
Okay, is number 4 linear?
No.
Oh, that's sad. Is it? Okay, so my x's are good, right?
Yeah.
Okay, but what about my y's?
No.
So I go down 1, up 3. That's not good. Okay, now random thought. Sometimes I have those. I want to have a conversation about whether this is linear.
Multiply 2.
Hold on. Let's do this. What's the change from 1 to 2?
They add 1.
And here,
Oh, it's adding
hold on. Over here, we're plus 2. Here, we're plus 2. And here. Okay, so what did I do?
It's like adding two numbers.
Didn't I like skip? I skipped a coordinate. So like, yeah, I know that these aren't like the same. But if I did put x's 4 here, would my pattern make sense? Okay. Tried to trick you. Didn't work on some of you.
What if 5? What is x 5?
I was absolutely
5 equals x and y equals 11.
Not gonna work. Nope, not gonna work. Okay. All right. Now, when we look at equations, notice how in this one, y and x don't have exponents and they're separated. This is a linear equation. However, over here, do you see how x has an exponent? That's not okay. Since that exponent is a 3, it's what we call a cubic function, but you don't have to worry about that this year. No. Hey guys, is number 7 linear?
Yes.
Is number 8 linear?
No.
Ah.
It's gotta be going. It has to be going all.
So here's the deal. I would say that this is a linear function, but it's discrete, so we're only seeing the dots. But we could make a line out of it, so we could say linear. Okay? There is a linear relationship. Okay? But all I really cared about is it continuous or is it discrete? Okay?